Oh, hello, Morgan Labs. Today we're going to talk about waves and interference. So basically, when you talk about interference and waves, waves are overlapping each other, right? So if it's like in this scenario where these two waves are overlapping, you would have the combined wave. It would be constructive interference, and it will look something like that. Okay. Clear that out. So your phase angle would be 0. No shifting between the two waves. So now let's go opposite. Totally out of phase. We would have destructive interference. The phase angle would be non-zero, and your kind of resultant wave would kind of look like just a straight line, because everything would cancel out each other. And then you have something in between, right? Which is what we're going to do in our problem today. Right? Let me clean that up. Okay, so what we have, find the phase angle between two sinusoidal waves when the total amplitude is 2. Wave 1 is 1.5 meters. Wave 2 is 3 meters. So right off the bat, we know that if our total wave is 2 amplitude, that means it can't be 0. Phase angle phi cannot be 0 because your total amplitude would be 4.5. Okay. Just a sanity check. If your phase angle in the end gets to be 0, you know it's wrong. You know something's up. So then what we do, we just use the standard equation for oscillations frequency. X is your displacement, A is your amplitude or max displacement, sine, and then omega is your radians per second, T is time, and then your phase angle. That's what we're talking about today. And so what we do here, we set up the equation for two waves, but we use the same formula, basic formula. So we plug in 1.5 for A, and then we just arbitrarily make one have a phase angle 0, okay? And then the other one will just kind of be referenced from that. So this one, our phase angle is 0, and then our wave 2, we'll put a phase angle in there. And that's what we're going to solve for. Okay, should be straightforward from now on, right? Hardest part is just knowing the concept of phase angle. Just means when you're shifting two waves and how they interfere, and then you got to connect it with the equation. Okay, let's go for the next part. For the amplitude, the total amplitude, we know from the unit circle, your maximum value when you have a trigonometric function, like when you have a sine function, is going to be at 90 degrees. Okay. If you remember a unit circle, it's 1 is the radius, and then the dots, the quadrants, correspond to your value of cosine or sine. right? So at 90, it's 0, 1, right? So cosine of 90 is 0. Sine of 90 is 1. So at 90, we have 1. That's the max. So you could have memorized that, but that's just the way I kind of remember it. So I guess I don't have to memorize it. Anyway. Basically, you need 90 to be omega t. Okay. So we're going to plug in 90 for omega t. And we're going to say a total is 2 meters. And then we're going to solve the equation. Okay. So that's what we're doing here. Okay. X is 2. And then 1.5. And then sine 90 degrees is 1. Plus 3 sine 90 plus 5. Okay. So we do a little algebra here. We bring the 1.5 to the left-hand side. Okay. Divide by 1. Oh, no. Subtract. You subtract 1.5 on both sides. And you get 0.5, and then you just kind of get a 0. And you're kind of left with this. And then the next step, we divide both sides by 3. That's how you get the 3 on the left-hand side. And after we do that, we get 0.166. And then to reverse your sign, all you have to do is do arc sine. So here, make sure your calculator is in degrees. This is a common mistake that happens a lot. Make sure your calculator is in degrees. And when we do that, we get a number like 9-ish for the arc sine of 0.166. And then you subtract 90 from both sides, and you get your answer, negative 80.4. So to have a total amplitude of 2 with these parameters, right? Your phase angle has to be negative 80.4. Okay. All right, that's it. Hope you learned something. And phase angles, you use them in circuits, voltage, current, waves, or signals, leading, lagging. Depending on the phase angle, your circuit will be resistive or inductive or capacitive. That's just how you would design your circuit. Other ways, maybe controls theory, when you're wanting to do different, control different things, or like Fourier series when you're trying to put together a lot of functions to make something else. Anyway, that's it. Hope you learned something, and I'll see you later.